In chemistry, intercalation is the reversible inclusion or insertion of a molecule into compounds with layered structures. Examples are found in graphite intercalation compounds. Many layered solids intercalate guest molecules. A famous example is the intercalation of potassium into graphite. Intercalation expands the van der Waals gap between sheets, which requires energy. Usually this energy is supplied by charge transfer between the guest and the host solid, that is, redox. Two potassium graphite compounds are KC8 and KC24. Carbon fluoridesx and, are prepared by reaction of fluorine with graphitic carbon. The color is grayish, white, or yellow. The bond between the carbon and fluorine atoms is covalent, thus fluorine is not intercalated. Such materials have been considered as cathodes in various lithium batteries. Treating graphite with strong acids in the presence of oxidizing agents, causes the graphite to oxidize. Graphite bisulfate, C24, plus, HSO4, is prepared by this approach using sulfuric acid and a little nitric acid or chromic acid. The analogous graphite perchlorate can be made similarly by reaction with perchloric acid. Aside from graphite, well-known intercalation hosts are the layered metal dichalcogenides such as tantalum disulfide and iron oxychloride. In characteristic manner, intercalation is analyzed by X-ray diffraction, since the spacing between sheets increases, and by electrical conductivity, since charge transfer alters the number of charge carriers. Exfoliation, an extreme case of intercalation, is the complete separation of the layers of the material. This process is called exfoliation. Typically aggressive conditions are required involving highly polar solvents and aggressive reagents. Related materials, in biochemistry, intercalation is the insertion of molecules between the bases of DNA. This process is used as a method for analyzing DNA, and it is also the basis of certain kinds of poisoning. Clathrates are chemical substances consisting of a lattice that traps or contains molecules. Usually, clathrate compounds are polymeric and completely envelop the guest molecule. Inclusion compounds are often molecules, whereas clathrates are typically polymeric. Intercalation compounds, which are not three-dimensional, unlike clathrate compounds. According to IUPAC, clathrates are inclusion compounds in which the guest molecule is in a cage formed by the host molecule or by a lattice of host molecules. Notes. See also, clathrate compound, where a molecule is included into a lattice, stacking, graphite intercalation compound,